Cool. So, hey everyone, I'm going to be talking about event storming. I'm going to start with a few kind of theoretical things, so hopefully it's not going to be too boring. Before that, I'm Martin. I'm a software engineer. I've been a product manager as well, consultant. Those are some of the places I've worked at. And most recently, I've been working at Argos. For the past few years, I've been sort of interested in what it means to have a high-performing team culture, high-performing sort of delivery system for software engineering. And this is what led me down the rabbit hole of topics like event storming. I have this sort of naive idea that maybe if I share more about these things and people kind of spread the word about these practices, maybe there's going to be an uplift in the quality of engineering that we do in our jobs. So I want to start with a rather naive, sort of almost silly question. What's the goal of software engineering? I love these questions because often they have a lot of nuance, there's a lot of debate, and they can bring out the real fundamentals of something. So you can say maybe it's writing code, but to me, this is just the artifact that we produce. It's just the output of our work. And if I were to compare it to something else, to me, it feels like saying football is just about kicking a ball. It's not just that, because it's there are all of these other processes that are higher level on top of everything else, kind of like collaboration, the strategy, the tactics, all of that stuff. You can say it's about shipping features, but I wouldn't say that's quite there yet as well. There are a lot of features that get shipped that don't end up being used, a lot of products that don't get used, and so on. I really hope nobody answers this. So what would you guys say? What's the goal of our profession, software engineering? Yeah?
Satisfy the product.
Yeah, good answer. I like that. I think that's pretty much what I would say as well. We turn this into that. We have some sort of real world process, which is exchanging money, for example. By the way, this is total coincidence that does payment related stuff. But essentially, we have some sort of real world process. We have some business transaction, some sort of concept, a bunch of users, and we encode this into software. We produce a software which runs and serves some sort of need for a customer, whether that's your banking or scrolling cat videos on Instagram. It's fulfilling some sort of need for the user. But there's a thing. Everyone sees the world in a different way. And I'm sure you've seen one of these things where it essentially shows how people view reality from different lens, right? Everybody sees their own corner of the universe and not necessarily the full picture. And that's exactly the case with software. This is some sort of payment service where you have your account object with a bunch of different methods like credit and debit. You have your payment service which facilitates this. This is essentially semantically the same piece of code facilitating a transaction, a transfer, but the sort of responsibilities are inverted in a way. You have a transfer object which executes some sort of action on two different accounts, and it governs the rules of how the transaction should happen. This is a real piece of code that I've seen. It's actually a screenshot, and it shows another type of way of looking at reality from a different angle. Those are two pieces of code from two different services, which should ideally map to one another. My task was to map from one to the other. And at first, I was really confused because it made no sense. We have promotion type, discount, voucher, and code. How the hell do I map this to single-use coupon, multi-buy, multi-use coupon, or generic? To me, those are not the same thing. It made no sense. Another type of viewing reality from different angles. let's say we have a meetup doc, such as the one that we have here right now. You can have a proposal for a meetup doc. You can have a schedule, you can have speakers, you can have rating, you can have it filmed and posted on YouTube. And those are not necessarily the same things. Sure, they are part of the same sort of process, the same domain. But if you were to have, let's say, one giant table with all of these things, you have a model which is very bloated, and it would be a pain to deal with in a real world application. Any sort of change would affect multiple other things, and it would be very difficult to work with. What I mean to say with all of this, when people view reality from a different angle, you get model choices that reflect this. And your model choices, by model, I mean what you encapsulate in your software code. You get different trade-offs. Your model will be wrong most of the time and right only some of the time. So this is all due to silos. Knowledge silos where different teams or different people accumulate only a part of what there is to know about a system. There's this guy, Melvin Conway, who came up with this observation. He observed that the design that gets produced from an organization is directly influenced by the communication patterns and the communication structure within a company. This is a real message that I've received. So it says, the original message broker flows were written a long time ago. No one is around who built it originally. The microservice was written to replace flows a while back. Those engineers have since left too. It's a very common scenario. There's a piece of code which someone wrote, they didn't necessarily share or spread the knowledge, and now nobody wants to deal with that. Everybody wants to just stay away from that part of your code base. This is another way of representing this whole thing, where some knowledge is shared. There's some sort of diverging opinion somewhere. Nobody knows about some portions. This is that previous slide here. One that I like is the Ask Bob circle. I swear that every company has this one person who knows, like, I don't know, 80% of the code base, or like a really niche part of the code base, and he's like the go-to person for a whole lot of stuff. And his time is just clogged with people asking him for knowledge that nobody else has. So this is one of my main points here. How, when, and what information gets shared within a company is one of the most crucial things in a software team. This is a direct consequence of having bad communication patterns. This is the information bottlenecks bingo. Outdated documentation is a classic one. Joining a new team. How do you get up to speed with a new product that you've just joined and there's been like maybe years of development? A lot of the times, at least some of the teams that I've joined, you need to speak with, I don't know, 10 different people just to understand one whole flow or process. Or another one that I like is, it happens very often, where you need to organize a meeting with someone, you prepare some questions, not all of them get answered, you then need to go back, you need to check a few more things, you need to organize another meeting in 5 days' time, and a simple change can grow in scope and drag over multiple weeks just to develop something. This is my main point here. It all comes down to feedback loops. It's a concept which is hopefully very intuitive, but imagine you have, you're in a cold room, and you have a radiator and a thermostat. But let's say your radiator is very good and your thermostat is very dumb. Let's say your thermostat can crank up the heat in like 5 minutes, but your thermostat only registers changes in temperature every 2 hours. By the time it registers its first measurement, you're going to be in a sauna, basically. And an obvious question here is, what does this have to do with software engineering? This is just an example of a feedback loop, but in software engineering, everything has to do with informational feedback loops. And those are some of the feedback loops that we have to deal with as software engineers. Is our product useful? Metrics like usage metrics for certain features, certain parts of the product, or revenue can indicate this. If you go one level deeper, you have your individual code metrics. Let's say, is my test doing its job? You verify this with tests. Does it perform well? You do your performance tests and so on. But the not so obvious informational feedback loops are, is my model good? Have I produced something which is resilient to change? How often do I need to change it? And those are the type of questions that make your model good or bad, as well as the shared understanding. Like, how many meetings do you need to go through? Informational feedback loops about the model. Those are the types of questions that I am interested in, because they're a bit more vague, but I think they reveal a lot about the model. And this is how you get into this type of mess sometimes, which is quite common in a lot of companies. We have a lot of silos, which increases the cost of consensus. We have this sort of fragmented knowledge scape. It's hard to make decisions. People are afraid of breaking things, and you get a clogged organization. So if there's anything that I would like to emphasize, it's this: having those feedback loops, sharing information about the model, constantly checking, is my model reflecting reality and how we expect our software to work? It's one of the most important questions in software engineering, in my view. And this is why we have event storming, finally getting to event storming. So this is Alberto Brandolini. He's an Italian developer who, off the back of the domain-driven design movement and event sourcing, not to be confused with event storming, came up with the concept of event storming, which is a workshop format. It doesn't solve all of the issues that I described previously, but it definitely can help with a lot of them. And what is it? It's a workshop format. So what I'm going to show you here, they are just guidelines. They're not strict rules for running a workshop with event storming. The aim is to develop shared understanding around the problem, around the model, around what it is that our software needs to be doing. The way to do this, it uses a very simple notation with sticky notes and just a blank canvas. To give you a good idea of how it looks, this is a physical event storm workshop. This is the sort of output you can expect. We have a lot of colorful sticky notes, which represent different parts of a system and different flows within a system. These are some of the sticky notes that you may use, and this is the basic notation which you're going to be able to learn now and be able to apply it tomorrow. The main sort of crucial part of event storming is the domain event sticky note, which is the orange one, the first one. It needs to be in past tense. It needs to represent something that both developers and the business can understand. And it represents a state transition. It doesn't necessarily need to be that you have an event-driven architecture system or anything to do with events and sending of events, nothing related to Kafka and stuff like this. You can treat those as just a state transition. You have the command notation, which is in imperative form. So it's when a system or a user is performing some sort of action, which would typically result in an event, or can not. It doesn't have to. We have the read/view. It's a sticky note which shows that there's some sort of information being relayed back to the user. Yellow sticky note is for a user, or maybe it could be another system performing an action. Pink one represents an external system, which you're not concerned about in the scope of your event storm session. So it could be some sort of external API, or if it's the scope of an individual team, maybe it's some other team's API that you're calling. Purple one represents some sort of hotspot or potential issue, maybe a potential opportunity for something that the team can work on. Problematic areas, questions, unknowns, that type of thing. How to run an event storm workshop. You basically have someone facilitate, you send out a bunch of invitations to relevant people. It's good to have representatives of multiple different teams that are relevant to the systems you're mapping, just because you need that sort of domain knowledge and you want to capture that. The way to do this, you start off with a single kind of like a brainstorming session almost, where everyone lists as many domain events about the system they can think of. They put them out on a board and then they arrange them sequentially. From there, a lot of discussions can start. It's particularly the case with larger groups of in-person event storms, where you can get, let's say you have a group of 20 to 30 people, and those can easily break down into smaller subgroups where maybe there's an interesting discussion going on, maybe there's a debate of how exactly the system works, but those are the kinds of things that don't necessarily translate super well to an online session. You can still do it online as well. I've done it, it worked as well, where you can use breakout sessions to have those smaller group discussions. And it's also worth having someone narrate the whole story backwards as well, because sometimes when you start with the end state of some sort of user flow, you can easily discover things that you missed along the initial sequential way. It's good to have a round of just highlighting potential problems and opportunities. There's something called the arrow voting stage as well, where everyone sort of highlights the things that they are interested in as a topic of discussion. So now, to show you what the outcome of an event storm could look like. As I mentioned, I currently work at Argos, and this, it's not something that we've done together with my colleagues. I did this just as a mock-up for this session. It doesn't necessarily reflect exactly how our flow works, but it's just representative. Imagine you have a bunch of items added in your cart, and this sort of model currently represents the checkout flow. Those are the types of events you may list in your board. Delivery slot selected, payment added, and finally you would end on an order placed. The next step of your event storm session would be something like this, where you list everything sequentially, you arrange everything in the sequence that represents how the flow should work. This would be essentially what your customer sees, how they interact with your system. And this can literally read like timeline, almost like a story. People like stories. It's very easy to think in stories. So that's why this is a good way of representing the true state of your system. Here you can see I've represented external systems, which I don't care about at this stage, as pink sticky notes, like the order system or fulfillment system, which would be called. And finally, when we start adding a bit more detail, it would look something like this, where you have a user adding items to a cart, going to the basket page, and then starting the checkout journey. This vertical line here represents a good sort of cutoff point. And if you go down the route of like proper DDD modeling, this in itself could be a separate bounded context. This can be a bounded context, and so on. So once the checkout session gets started, you have some sort of orchestration service. This is the purple-ish sticky, which I don't think I mentioned on the previous slide. But essentially, we go into two different flows. We have a delivery journey and a collection journey, where a few slightly different things can happen. For example, the delivery journey, you need to select an address. The collection journey with Argos would be you get your items shipped to a physical store, so you don't need to, you select this beforehand. You don't need to necessarily go through that again. And once you've selected an address, you get presented with some sort of payments view where you add your payment card, and then you place the order with the place order command. Here, let's say you have some sort of concurrency issue with adding payment methods to your session. You can highlight this, and this could be a topic of conversation. You can dig deeper into it afterwards with all of the discussions that you have with your colleagues. And then this can be your cutoff point. After that, you pass on everything to your order system, and depending on the scope of your event storm, this is the output. This also can double up as a documentation as well. So, which is why I mentioned joining a new team can be very beneficial with something like this, where a new team member can easily sort of see at a high level what the system is doing, when it's doing it, and so on. So, going back to this, those are the key points that I wanted to highlight. It encourages collaboration by seeing those flows laid out. A lot of people may notice things that maybe should not be the way that they are, or you just get to talk about the process, the states of your system, and so on. And it really bridges the gap between product people and tech people. Software engineers, they care about things like databases, Redis, Postgres, and so on. Product people wouldn't necessarily care about this. But by doing an event storm session, you bridge that gap and you talk about the problem that you're modeling in facilitating those conversations. It's a collaborative problem discovery tool. And it also reduces those feedback loops that I mentioned, where instead of going back and forth with multiple different teams, product people, software engineers from other teams, and so on, you get to sit together and have the conversation, map out the system, and find some of those unknowns much quicker. There are a few different formats that you can do with event storming, and the orange sticky, which is the domain event, is the common thread among all of them. The big picture event storm, it basically aims to represent a full system. So this one, it can you can spend a lot of time, maybe even multiple days, just mapping out an existing system, or if you're discovering a new system, trying to plan for how you're going to build it. It can take a long time because most real-world software can be quite complex. During a big picture event storm, you would focus on the more high-level pieces like systems, actors, maybe hotspots in the system. Then you drill down to individual processes. At this point, you care about the commands and read models. If you want to get even closer to the code, you can do that as well with an event storm session. This is where doing like proper event sourcing and domain-driven design can be really beneficial, because it helps you sort of find those aggregates and the domain events. I mean, you've already laid them out on the board itself. By the way, I've even seen a Miro plugin which takes the event storm output from Miro, and it generates code with I think it's the Axon framework. So it was just a cool thing that I saw. You can literally generate code with a Miro board. Not necessarily best practice, but these are some extra resources. I'm happy to share the slides afterwards. But introducing event storming is the book by Alberto Brandolini, who came up with the concept. It's not 100% finished. That's why it's on LeanPub, but it's still a very good resource if you want to dig deeper into this. There's a Miro template and a Figma template, which can get you started with event storming sessions. Event modeling, it's kind of like an extension with a few more rules and guidelines on how to model a system. And event storming DDD talk, this is again by Alberto Brandolini on one of the conferences that he's attended. So before we get into any questions, I wanted to mention I do want to start offering some sort of consulting service, which is to help product engineering teams to adopt some of those practices that reduce the feedback loops. My main offer right now is the idea to essentially do 4 to 6 weeks of a sort of part-time work to discover bottlenecks, basically analyze the delivery pipeline within the company and produce some sort of roadmap on how to improve that. I am going to have limited time because next month I have a very important release date, which is the birth of my first kid, and I'm not going to be able to do more than 1 or 2 clients at a time in the near future. So happy to keep in touch and talk about stuff like this. I do have like a quiz assessment thing in my website, which basically gives you a quick sort of score of delivery practices within a company. I've also got links to my LinkedIn if anyone wants to connect. So yes, that's all. Thank you so much.